All right. Now, Module 1, Electrical and Electronic Engineering Drawings. The instructor will be Geoff Botrill. Geoff is a very, very good instructor. He's a very experienced instructor, and he knows what he's talking about. He's been a professional in the industry for a very, very long time. So I encourage you to make the most of the Module 1. But now, what I'll do is I'll hand you over to Peter, the special guest speaker for today. Thanks for coming, Peter.
Oh, I do agree. There goes the applause for Paul. Nicely done. Nicely done. I like this thing. So once again, volume check. And I'm going to do the same thing. If you can hear my wonderful voice that you'll be very sick of in a few minutes, please give me a smiley face. Oh, that is so nice. Thank you. Oh, my goodness. I even got one from IDC Room 1 or whatever it is. Wonderful. Anyway, so thank you. I have an orange hat, hence the picture in the lower right-hand side. I appreciate all of you actually taking your time because, come on, this is non-trivial for us around the world to get together and try to walk through a lot of the, as it says here, electrical and instrumentation engineering that's specific to mining. I think you're going to have a blast doing this stuff. So I was kind of curious about this, and Paul, a few minutes ago, is listening to individuals that are in the UK and Tanzania. You know, it's pronounced different ways, and certainly in South Africa, and then you're in Australia. Try to make like a little indicator where you are. I am on there, the east coast of the U.S. Grab the icon of your choice in everyone and put a little mark on the map on the page here and sort of show us where we are. Wonderful. Okay, well, at least two of us are there. Ah, yes, I love the smiley face. That is perfect. The time zones are really something. Paul, I admire your enthusiasm at 1 a.m. or after 1 in Perth. That's great. So thank you for that. This is quite the nice tool. A number of us, I'm an old timer, and so a number of us have done web seminars for a long time, and this is a nice interactive tool. Really, really great. So thank you for that. Let's just get on to some of the details here. So when you look at electrical and instrumentation engineering, and of course this is like an overview of a wide swath of material. My goodness. So I just grabbed some standard pictures, and I'm not sure, I have a guess, but I'm not exactly sure which type of mining individuals are really interested in. So maybe you have like a large open pit mine that you or colleagues are working on, like you see in the upper right-hand side. There are specific challenges, as you can imagine, in each one of these settings, but yet there's a commonality in terms of instrumentation and in engineering specifically. On the lower right-hand side, of course, that's you're doing some strip mining, classic case. And it's interesting to see the instrumentation similarities and then differences between those two places right there. Strip mining has its own stuff, obviously, and there's a big open pit. But there's more than that. So I was looking around here, and basically, you know, let's just get this right out of the way. I'm an electrical engineer, but I was a professor for a long time, which basically means I'm long-winded. So just watch out. Fire away with email. You can draw on the screen, not email, whatever that chat room thingy is. Draw on the screen, raise your hand, whatever. So interactive, man. Interactive back and forth when you have questions. If you look inside the engineering discipline itself, it is very broad. I mean, it's no big surprise, but it is really broad. And so inside there, you can have chemical engineers, and of course, double E's, and mechanical engineers, and you know, petroleum engineers, process engineers, computer engineering. There's a wide range. And inside the disciplines of engineering, here's what mineral and mining engineering actually has as its core focus. This is as a discipline, and this is who we're supporting. If we're in the instrumentation, we are these people. But not only, there are experts that are looking, like it says, explore land, the ocean floor, Earth's core, asteroids, and of course other places for ore and mineral deposits. Along those lines, I worked at NASA, the space agency here in the U.S., for a number of years, and we were looking at doing mining on the moon, and certainly ore and mineral recovery on the moon Titan. If you're familiar with that, look out in the big planets out there, Jupiter and Saturn and so on. Titan looks to have some pretty interesting mining materials. So from a NASA perspective, there are mining engineers that are specific to NASA, and we're looking at not just terrestrial mining, but how you do it literally out in outer space. It's pretty wild. And I'm not talking about the movies like whatever that Bruce Willis was, where a bunch of mining engineers and we're going to destroy an asteroid and save the planet. Hooray, 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 whatever. But the mining engineering technology focuses on this stuff. What do you do for open pits? Like I said, if you have a tunnel itself, if you are on the chemical side of processing, that's its own wizardry. And like it says on bullet number 3, right down here, it's basically like, hey, look, you're going to purify and separate minerals through chemical and mechanical processes, and so on. A lot of that can go right over towards some of the same applications, in fact, some of the same instrumentation that you find in petrochemicals. And about 2 weeks ago, I was involved in quite a meeting in South Texas here in the U.S., where we have a very large shale gas deposit, or a big play. And there is trying to look at environmental friendly ways to do drilling at 15,000 feet, vertical shafts at 15,000 feet, then you go horizontal, and then you inject all sorts of chemicals and water, and you do fracturing. And so it's called fracking, but basically it's injecting things down underground to pop open, what the heck is that? To pop open the rocks, and out comes the natural gas. The reason I mention that is because what you need from a technology base is really similar to what you find in all sorts of mining. And of course, go build a subway. A lot of the same ideas come into play. Maybe you're interested in these other types of mining activities. And so up in the upper left-hand side on this slide, this one over here, it's showing, this is mountaintop mining. So, it's very, very prevalent here on the east side. We have a mountain range called the Appalachians, east side of the U.S. And, this is used a lot, as we all know. And then the lower right-hand side, well, I bet a couple individuals, a couple of us that are participating in this class recognize where we are there. Anyway, so there are, once again, it's the similarities between instrumentation. Yeah, Jacques, I totally believe it, man. It's like, it's the instrumentation that can play inside every one of these domains that you're going to gain the core knowledge on. And you can transport it to other places. So if you're underground or you're doing an open pit, a lot of the same techniques and instrumentation are at play everywhere. It's a pretty wild idea. So once again, looking at electrical and instrumentation, E&I engineering for mining, I grabbed this simple little diagram that shows a life cycle of a metal resource. And although it could be other types of mining, this particular graphic showed, okay, we're going to do surface mining, and then you start to actually do some processing, and away it goes. And you can see we're over on the left-hand side. Actually, let's do extraction and see how things come into play from an instrumentation perspective in that arena. Sort of makes sense to everybody? Sort of? Sort of. Oh, well, let's give it another try. Thanks, Matt. Thank you. So let's give it this other try. Here's another graphic that is looking, and thank you, Jacques, if you're looking for open pit mining, then what you could find would be something like this graphic that sort of shows what happens in contour types of strip mining. It's not a big surprise. Somebody finds the scene, obviously this is a coal graphic. You find a coal seam, you dig down to it, you set up a high wall, dig out the coal, and put it into some big mechanized machines or whatever, and transport it off. And the trick here is thinking about the instrumentation that comes into play, not only in those machines, but in the other stuff that supports this entire activity. There's a lot. There's a lot that goes into this, and I think you're in for one wild ride in signing up for this particular course. So, as our delightful coordinator, like our fearless leader Paul was probably wondering, who is this guy who's talking? And that's me. Like, you know, I'm just sitting here, like I said, I'm sitting here in Tennessee. What gives me any sort of credentials to try to talk about electrical and instrumentation engineering specific to mining? And so, well, my name is Peter Fuhr. And like I said a while ago, I'm an old guy. I have a PhD in electrical engineering, and I'm a material science person. I've written a lot of papers. I do a lot of work. I was a professor for 19 years. I've run companies large and small. I'm currently working in one of the national labs here in the U.S. called Oak Ridge National Laboratory, and I have a lot of activity that's related to sensors. I'm a sensor and wireless guy. There are standards out there that a lot of companies are building their products towards, and the companies range from Emerson to Honeywell to Siemens to Yokogawa to Invensys, ABB. The list goes on and on. And as they're trying to put wireless on top of standard instrumentation that you're going to find at your mine right now, or the DCS people themselves, they're looking at wireless, and I chair a lot of these committees. So I just run into a lot of people. I deployed sensors up on all sorts of stuff, offshore, out in space, that's way offshore. Put sensors inside devices, all sorts of stuff inside nuclear containment vessels in France. Bunch of stuff that's happening. Integrated wireless, I have put sensors inside dams, designed this fuel gauge system for the F-22, blah, blah, blah. What really matters is for 15 years I've been involved with sensors and instrumentation for mining activities. So here's what's going on. And Ben, I think you're going to be able to pick this up on the recorder or at another date, no problem. You'll still get the graphics. Working with Chevron, we were looking at coal mining. This is surface mining in the U.S., where this particular activity is in the western part of the U.S. in a state called Wyoming. And it's instrumentation that goes along with this particular surface coal mine. I want to bring this particular point up because they at Chevron were looking to just buy commercial off-the-shelf material, sensors or instrumentation from Emerson and Honeywell, and they have a demand. They have a flat-out demand for radio silence. And it's not a big surprise because as you're blowing out the side of the hill with some explosives, you turn off most of your telemetry systems, your wireless transmitters. And this came into a standards organization that I helped run as the requirements from the industry, from the mining industry saying, hey, we'd like to use this instrumentation, but you have to verify to us that when we say we want radio silence on these pressure gauges, temperature gauges, whatever, make sure it actually goes radio silent. And through the course of this, working with about 100 really smart engineers, we were able to force through in this standard a requirement that says if you buy ISA 100 equipment, it's going to, and you send it a command saying, shut up, it's radio silence, it'll actually do that. Once again, this is a coal mine, it's a graphic here, but it's associated, with Chevron. On the lower right-hand side, a couple of years ago, and I'll come back and bore you guys with this, a couple of years ago, I was up in a uranium mine about 600, 700 meters underground in Canada. It's up by the Arctic Circle. It was cold, and it's a uranium mine. And here's a picture that I took as I'm driving a Jeep down this thing. We'll talk about the instrumentation that goes into this particular activity because you're going to see it inside the courseware in a little while. I mean, it's pretty wild. There's a complete distributed or discrete control system, a DCS that's underground at 625 meters underground inside a radioactive environment because you're processing uranium underground underneath a frozen lake. It's a wild activity. Well, I think at least two individuals, if I get this right, certainly recognize this sort of picture on the upper right-hand side. That is a representative graphic of a gold mine. In the year 2000, I was in Johannesburg for a number of months, and then we would travel around. We were working in gold mines in South Africa, trying to embed fiber optic sensors in the shafts that are plunging down into the ground, and we would put fiber optic strain gauges on the outside of the wall or the wall itself on the